Hello and welcome. Today I would like to talk about research methods in MBA. Okay, so let's write the title. Okay, so there is two types of research. It depends on quantity and quality. Quality means we're looking for specific information and we collect this information from interviews, observations, surveys, whatever. Okay? And quantitative, which is we collect the data from numbers, statistics, measurements. Okay? So there's generally 6 steps of research process. So if I want to do a research about something, there is usually 6 steps, okay? So the first step, which is define the problem. To know exactly what you're looking for, what is the problem, the correlation that you're looking for, okay? So define the problem. So I want to make a study to connect smoking with lung cancer. So I already know what I'm looking for. I want to look for the correlation, if there is a correlation or not, between smoking and lung cancer, for example. So I know exactly what I want to measure. I want exactly what I want to look for. The second step, which is review information, existing information. Review existing information. I want to see what already I know, okay? Because that small piece could sometimes help you solve the puzzle. The data, what was the available data about it? What is the sources that I could extract information from it? Thirdly, you have choose the method. We talked about it right now. What is the method that I want to use? Okay, now I'm going to talk about sampling and different types of sampling just after like a few minutes. Okay, so I want to choose the method of research. Is it a research that I want to do in a hospital? Should I go and interview patients myself? Should I go and ask people on the streets? Should I do whatever, okay? Fourthly, collect data. The actual process and a study or a research without data, especially in scientific studies, is nothing. Okay, you have a claim, a hypothesis. Blah 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 is related to blah blah blah. X is related to Y. Okay, but you don't have a data to prove it or not. Okay, so collecting the data, and we do use that already, as I said, using interviews, surveys, interviews, whether online or face to face. All of those things. Observation sometimes. Okay, you could go and see things by yourself. Fifth stage or step, which analyze the data. Okay, here's where the mathematical part actually exists. So I could calculate the average. I could calculate the standard abbreviation. I could calculate something using math and statistics law to analyze my information. If I want to see, like, for example, what is the average height for students in the 9th grade, for example, whatever. I measure the height of all students, okay? I have like 5'7", 5'8", 5'9", 5'10", whatever, okay? Then I'm going to use analysis. I'm going to collect the data, measuring the students' height. Then I'm going to use analysis. Okay, I'm going to find the average of the heights of the students. in this class. Okay, so it would be like 5.9, for example. So I used here a mathematical tool, or the standard deviation. Is all samples similar or fit in the same range? Okay, so when the standard deviation is small, I know that all samples are similar to each other. Okay, when it's big, means samples are not. For example, I want to see what is the usual or likely age that people die of lung cancer, for example, something like that. So I would collect data about, like, it would be like, I have seen dead patients records, and they're like their ages when they died, like 70, 75, 80, 85. Okay, so it's consistent. I could say, all right, they're in their 70s. For example, this is not a real scientific study, just for example. So I would say the standard deviation here is small, because all samples is fitting within the same or range, 70s. But if this sample was like, one of them was 25, the second is 40, the third was 85, 90, 104, for example. Here the standard deviation is big, because you're going to compare the average of these numbers to each value. This is how we calculate it. Okay, I'm going to talk about this in more details maybe later. Now the last step, which is report what you have found. Report finding. Okay, so you're gonna say eventually the conclusion of your research. There is a relationship or a correlation between X and Y. There is, or smoking is a cause by, or lung cancer is caused by smoking. Okay, in 70% of the cases that I have seen. Okay, this is a scientific conclusion based on scientific methods. Okay, now sampling. What is sampling? Sampling means those people or whatever, whatever I was studying. So how I could collect the data? Okay, should I go, for example, I want to prove that smoking is not bad. Okay, so I would go, and I know a lot of people who smoke, and they are like in their 90s. So I want to say that smoking doesn't cause people to die young. So I would go to the people that I have choose. They're old. Imagine this would be so ridiculous, of course. And ask them, and I would say, all right, I have seen 10 people. They are in their 90s, they're smokers, and they're in a good health. This is not a scientific way, because first I was biased, because I already wanted to prove something. Second, the sampling was not objective, or I was not being objective, because I have chosen specific people, okay, to prove something specific, because I already know what I want to do. Okay, this is not how decent research is done. Okay, so sampling is either the first, which is a probability, they call it probability sampling. Okay, equal chance of being selected. So I will go and ask all patients or that smoke, or people who smoke, regardlessly of anything. Okay, and the second type of sampling is non-probability sampling. You choose samples based on convenience, judgment, but it's a lot less scientific this way. Okay, so if you want to do, it's a lot better to do actually probability sampling. Okay, you choose your samples blindly. So of course we have talked about data collection tools like surveys, interviews, observation, experiments. Okay, so now we want to talk about similar terms, which is validity. They say your research is valid. Okay? Which means, are you measuring the right thing to begin with? This is what means it's valid or not. Okay? You want to measure something, a specific factor, but you can't determine which factor you're measuring. Okay? So in this case, there is no validity. Your research is not valid. This very similar term, but different, which is reliable. Reliability. Sorry for my handwriting. Which is, are your results consistent? Okay, so does it make sense? Simply, this is what means something is reliable. It's not the same as valid. Okay, as in research. So now I want to move to something else, which is hypothesis. Hypothesis testing. If I have a hypothesis, if I have a hypothesis and I want to test it, which is whether it was right or wrong. Okay, which is a statement you want to test. You want to collect data, as we said, test the hypothesis, then you're going to accept it or reject it. And there's also two similar, very different, but also they usually come together, which is correlation and causation. Okay. So correlation is two things move together. Okay. They're not caused by each other, but they're correlated to each other. For example, when the sun rises, people go to work. Okay, I could ask myself, can people go to work when the sun is actually during the sunset? Yeah. So it's correlation. It's usually like that. Those two phenomena happen together, but they're not connected. Okay. I think about, usually when you eat something, when you eat a burger, usually you have something called, you have to drink. It's correlation. You can actually eat one of it by itself without the other. So it's correlation. They usually move together, they usually happen together, but not necessarily, or they are not caused by each other. Okay? So, for example, in the summer, the ice cream sales increase. Is it a correlation or a causation? It's a correlation. Why? Because, first of all, it happened because of a third reason. Okay? So, during the summer, the temperature is higher. When the temperature is higher, people eat more ice cream. Okay? But it's not because ice cream means more, doesn't mean that summer means more ice cream, because first, summer is not always hot. In some parts of the earth, summer is cold. Okay. Second, people could actually eat ice cream, and the rate or the sales of ice cream increase in different season. It's possible. They're not caused by each other. They're usually correlated to each other. Okay. Now, causation, something like when there is clouds, there is rain. Okay, because rain is caused by the clouds. Okay, no rain, no clouds, no rain. Okay, this is very so clouds and rain. Okay. So this is very important when you describe what you're searching for, to be accurate. To see the relationship between X and Y, whatever was X and Y, whether it was a relationship of causation or correlation. Okay. So we have talked about methods we're going to use: medium, average, standard deviation, whatever. Now I want to talk about ethics of research. What do we mean by ethics? Okay, keep the privacy of your patients. Okay, so the data that you're collecting, you have to remember this is data from people with privacy. Okay, this is very, very, very serious thing. Never even let anyone outside the research to take a look of the private information of the people you're dealing with. Even if it was something you think it's not important, it's important. Okay, this is because you have to be very, very, accurate and ethical here. Something else is don't be biased, which means, as we mentioned earlier, the example that I already want to prove something and I try to make fake research prove it. This is not how decent scientific researchers is happening. And manipulation, this is also common, to manipulate numbers, especially if the study that you do actually could help the company that you work for or run or own to sell more things. Okay? This is very also serious. You have to be very honest about the results, show it as it is, with keeping, of course, the privacy of patients. And no harming for people who participate in giving you the information in any form. Similar also to privacy issues. So this is why when a company, let's imagine company X is selling a product X1, and they did a research to prove that X1 is a very good product. Very good. Makes you happiest person on earth, blah, blah, blah. This is why people, when a company make a research about their own product, they don't take it very seriously in general, in healthcare or in any product, because they're not totally biased. They're not totally objective. They could be biased. Maybe they manipulated the results, even whether they noticed or not, whether they meant or not, showing the good samples, hiding the bad samples, blah, blah, blah. So this is why when a company make a research about their own product, people or the community don't take it seriously, or it's not something we could rely on. Okay? So if I want to make here just a little, I want to give example about, I want to make a study about what is the reported symptoms that was reported by patients who had multiple medical imaging. Okay? So I want to know exactly, we're measuring, for example, I want to measure the patient experiences, symptoms they reported. Okay? It's not on the biological scale. No, I want to just see what's the experience of the patient, whether they were satisfied or not, whether feel that this imaging actually solved their problem or made them go in a loop. Okay? Something like that. So at the population, I want to say, so the patient who had multiple imaging during, like, in the last 5 or 10 years, like more than 3 CT scans, more than 5 x-rays, more than whatever. Okay, my sample, I want to take a sample N of 100 patients, and they're from the age of 30 to 80, and they're males and females. And I could collect my data in 2 ways. I could go and ask patients directly during an interview. I could give them a survey they could answer by yes, no, not sure. Okay, I could ask them about whether they were satisfied or not, whether they believed it helped them, what is the symptom. I could take that from the interview. I could collect that, all data, okay, and I could apply the math, and my finding would be, for example, that in average, people had, in my sample, between the age of 40 to 30, for example, 40, 80, 4.2 images, okay, in the last 5 or 10 years. For example, 14% reported headache, 13%, for example, of course, this is not a real study, 14% reported feeling worried after the image, whatever, okay? So this is the findings of the research. And the conclusion would be the more imaging a patient had, the more worried they were about radiation, okay? They were less satisfied, okay? This is the conclusion that I could write. So this is simply what I want to talk about in scientific studies and research. Hopefully that was useful, and goodbye.